Number 51 is definitely a weird problem here. Not one that you see very often, but I wanted you guys to get a little bit of exposure to this concept right here, just in case it pops up again. We've got a linear function on the top, x plus 5, and then the square root of a quadratic function on the bottom. So don't write down what I'm about to do, guys, because it crashes and burns pretty quickly. I thought, okay, this isn't going to be too bad. We'll let the u equal the entire quadratic denominator, which would be a 4 minus x squared. So now we're in nice shape right here. This just becomes the square root of u down on the bottom. And then I thought, okay, I can take the derivative of that and get a linear function to match up with what's on the top right here. But this is where things got icky. This derivative is a negative 2x dx. Now I could get rid of the negative 2. That's not a big deal right there. But then I end up with x dx. And there's no accounting for this plus 5 right over here. Now, I mean, like, if it was 5 times x, then I could just put a 5 right here and a 5 out here, and okay, we'd be fine. But the adding actually makes that really, really complicated. So here's the way we do this one. As I said, definitely outside of the box. We're going to take advantage of the fact, everybody, that a binomial numerator over a monomial denominator can be split up into each term of the numerator over the denominator, a over c plus b over c. That's what we're going to do right here. We're going to make this first integral, x, all by itself, the first term of the numerator over the denominator, 4 minus x squared dx. And then we'll add to that a second integral now. That'll be the second term of the numerator, 5, but over the same denominator, the square root of 4 minus x squared dx. And now this really becomes two totally separate problems. This gets a little bit weird. All right, we're going to do a u substitution right over here on the left-hand side just to deal with this integral. And this is actually what I started to do a while ago. I'm going to let u equal the entire radicand of 4 minus x squared. Du then is going to equal a negative 2x dx, and what I really wanted was an x dx. So a negative 1/2 du is equal to x dx. So what does that do for us, guys? This now becomes the integral of, all right, the entire denominator now is just going to become the square root of u, and then the x dx, the secondary substitution, becomes a negative 1/2 du. So here's your du. I'll put a negative 1/2 out in front and a 1 on the top. I think we can deal with that integral in just a second. Plus, all right, but now it's time to shift gears, and I'm going to shift colors too. We're going to do, all right, I shouldn't use u twice, everybody, so I'm going to do a w substitution right over here on this side. Although, actually, now that I think about it, I'm probably not ready for that just yet. Hold that thought. What I think I'm dealing with right here for the second integral here, guys, I'm going to pull that 5 out in front. We've got the integral of now, and this is a 1 over, and I've got the square root of a constant minus x squared. I'm going to pull that 4 out with that trick I've done a couple of times before. So pulling a 4 out is going to put a 1/2 right there, that 2 being the square root of the 4 I'm about to pull out times the square root of. And factoring out a 4 turns the 4 into a 1 and the x squared into an x squared over 4. Okay, now where am I going with that? Now, I want the x squared over 4 to become u squared. So let me take the square root of both sides of that. Nope. U, there we go, is just equal to x over 2. I forgot my dx right there, guys. Sorry about that. And then that means that if I take the derivative of both sides there, du is just going to equal a 1/2 dx. And sure enough, there's the 1/2 dx right there that I can substitute with that. I just said a minute ago I shouldn't have done u twice, so I probably should have made this a w substitution right here, or whatever other letter you want to do right there. Okay, so what does that do for our second integral now? Right here, the 5 comes out in front. We've got the integral of fraction bar, and the denominator is going to be the square root of 1 minus, and the x squared minus 4 gets replaced by w squared. So there's your primary substitution. And the secondary substitution, 1/2 dx, just gets replaced by a dw. So I'll put a 1 up there in the numerator. Now actually, That second integral, which I thought was a lot harder than the first one, at this point is probably actually the easier one to deal with. I tell you what, I'm going to save a step here, guys. I'm just going to rewrite this as u to the negative 1/2 power, and we'll just reverse the power rule on that. So where are we here, guys? We've got a negative 1/2 times. We're going to take our u, raise the power by 1, so it's now a positive 1/2, and then divide by that new exponent. So dividing by 1/2 is the same as multiplying by 2, and that'll take care of that first integral. And then plus, we've got a 5 here, and I hope we recognized here that this integrand is just going to be the derivative here of the inverse sine of whatever w is. So 5 inverse sine of w, and of course we need to put a plus c at the end of that because we're really dealing with two indefinite integrals. So let's clean this up, guys. Maybe one step and we're done here. The 1/2 and the 2 cancel out, so we have an opposite of. U to the 1/2 becomes the square root of, and I forgot what u was, everybody, right there in green, 4 minus x squared. Okay, so that will go right there. And then we've got a plus 5 times the inverse sine of w, which was right here. W was x over 2. A plus c at the end, and I don't think there's anything else we can do to simplify that. So that should be our answer here for problem number 51.